Solving a fractional part equation as the set braces indicate. Now, x a member of R superscript minus just means the same thing as we're looking for real valued x's that are strictly less than 0. Okay, it's clear that 0 is not a solution here. Yeah, these brackets here, these set braces indicate the fractional part. And this is the standard definition, I think, for the fractional part. You subtract the floor of the number from the number itself. Now, let's do a concrete example here. Let's say we had, and this is sort of counterintuitive, or at least to me. We are looking for negative solutions. So let's look at this example, minus 2.4. Minus 2.4, okay? Now, so we're talking about the fractional part. Now, you would think the fractional part would be minus 0.4, but it's not. Okay, now let's take a look. There's some reasoning behind it, I think. There's two different definitions, I think, for this. But let's go ahead and put minus 2.4 right here. And again, I'm just plugging into this definition of the fractional piece. Okay, now notice that the minus sign belongs, all right? Now here's the part that gets a little strange. The floor of minus 2.4 is actually minus 3. Okay, and it's in keeping with the greatest integer function. Minus 3 is the greatest integer that's still less than minus 2.4, right? And so you see this actually resolves to a positive number. And again, I sort of had problems with it. I kind of see why it's useful to define it this way. You want the floor or the fractional piece to always be positive, I guess, is the main reason. But in any event, this is equal to 0.6. Again, kind of weird, isn't it? You know, to think of that as the fractional part when really for positive numbers, if this was plus 2.4, the answer would be 0.4 here. But this is the definition, for better or for worse, of what we mean by the fractional part of a negative number, okay? So let's keep that in mind as we move along here, because notice that minus 2.4, and what really drives this definition is minus 2.4 is, minus 2.4 is certainly greater than minus 3, right? So just the way the negative numbers behave compared to the positive numbers is what caused what was originally confusion for me on this minus 3, right? It's because you're moving in the other direction, right? You know, normally if this would be less than if these were both positive numbers, but as far as the geometry of the real number line, minus 2.4 is greater than minus 3, right? Now, so what that does is, this is also a truth right here, that the fractional part's always going to be a number between 0 and 1. I won't prove it formally, but it sure better be the truth. The fractional part has to, and it follows just from this really, but the fractional part has to be a number between 0 and 1. And that leads to this result right here, just processing the information. You know, since the fractional part of x is equal to x squared minus square root of 19, these inequalities follow. So what we have here is x squared is greater than or equal to the square root of 19, and x squared is less than the square root of 19 plus 1. Now it's important to get bounding on x squared because it gives us bounding on x. Okay, now let's keep going here. So now y'all notice right here, if you take the minus square root, you have to reverse the inequality, and that's why you get the less than negative 2 right here, okay? Okay, but notice just like this was less than negative 2, and we chose, this ends up being plus 3 right here, right? For the very same reason, the fractional part of x is going to equal to x plus 3. Because x is stuck between two numbers between minus 2 and minus 3 here, okay? Now, this number is actually bigger than minus 3, but x is stuck between minus 2 and minus 3. That means its fractional part will be x plus 3. In much the same way, minus 2.4 has a fractional part of minus 2.4 plus 3. In other words, this just boils down to minus 2.4 plus 3, right? It's the same kind of reasoning right here. So this is good news right here, because notice that we can just substitute the fractional part of x equals x plus 3 back into the original equation. Now, that's what I did right here. The rest of this will go relatively fast. Right here, I replaced the fractional part of x with x plus 3, and you get this quadratic, and you guys can verify that. Now, this is the result of applying this to the quadratic equation. This very next line, I didn't show all the steps, but this is definitely what happens when you do the quadratic equation. Here you have minus b, which is plus 1. Then you have 4 times 12, which is 13. That's where this 13 comes from, okay? Now, notice we are looking, remember, we're looking for x to be a negative number here. And so what we're going to do right here is just accept, let's get rid of this plus right here. Okay, get rid of the plus sign. Okay, so this is our proposed solution. Now this next part, so in other words, x is equal to 1 minus all this stuff here, right? Notice this is kind of a nested radical within a radical, so this is an interesting solution. Now we're going to check the solution. Here's our original equation, so let's check the solution, which is a step that doesn't happen that much in a lot of math videos. So again, fairly straightforward here to check it. The fractional part of x is x plus 3, as we've seen. Now when you add 3 to this, notice that 3 is 6 over 2, right? And so 6 plus 1 is the 7 you see right here. So this is our exact value for the fractional part of x. No decimals here. Okay, a lot of people like to use decimals here. I think it's better just to go ahead and keep doing everything in an exact form. All right, now also notice here, again, we're checking this so we know that the left-hand side is equal to this, okay? Now the right-hand side, okay, this is the computation for the right-hand side. Again, I'm using the solution, the minus solution, and I hate to keep going up and down here, folks, but again, we're using the minus solution. All right, and so that explains where this came from right here. Now the rest of this, folks, again, I hesitate to say too much. It's just fairly straightforward stuff. Now, notice what happens here, which is kind of nice, is that if you look at this, this is the same thing as right here. This would be the same thing as just 4 over 4, right? Times root 19. Now, a lot of you guys probably don't need to see that, but it's okay to multiply anything by 1, right? And that helps you to see why the square root of 19's went away. All right, you see we're just left with 1 plus 13 is this 14 right here, right? Okay, and again, subtracting root 19 from this by this common denominator process, this is going to go away, and this is our solution. Now notice this is exactly, if you cancel out, if you divide everything by 2, you actually get exactly what we found. And I'll just write the notation down here because I've written it down once for you guys. All right, so that's equal to fractional part of x. Now, again, there's our computation for the fractional part of x right there, right, folks? Now, notice, if you just simplify this by dividing by 2, you get this, right? So you see this checks, okay? So we're done. We actually proved it without using decimals or calculators. Now, so what we've done is checked our solution. In this part right here is certainly the final answer, incontrovertibly. Now, y'all, there is a positive solution to this too if you're interested. But anyway, that is the solution, and I hope you guys enjoyed.